question, three vectors are given A, B, C, and they are coplanar, which means the determinant will be 0, that is, the box product will be 0. And magnitude of C is given, that is root 3, and we need to find the value of alpha and beta. So first do the determinant, that is the box product 1, 1, 1, A coordinates. B vector coordinates will be 4, 3, 4, and C vector coordinates will be 1, alpha, beta. And the determinant of this whole thing will equate to 0. This can be written as 1 times of 3 beta minus 4 alpha minus 1 into 4 beta minus 4 plus 1, 4 alpha minus 3, equate it with 0. And here 4 alpha gets cancelled. 3 beta minus 4 beta becomes minus beta, plus 4 minus 3 becomes plus 1, 0. Therefore, from here we'll get beta value as 1. Now, one more condition is given, that is magnitude. Magnitude of C vector is given as root 3. When you square it on both sides, it becomes 3. Now, 1 plus alpha square plus beta square is nothing but 3. Beta, we know the value of beta, that is 1. When you do this, alpha square becomes 3 minus 2, 1. Therefore, alpha will be plus or minus 1. So these are the values of alpha and beta. In this question, it is given as A, B, C are the unit vectors, of which no two are collinear and also they are non-coplanar. So we need to find the scalar triple product of ABC if this is true. So we got a hint over here that all three vectors are the unit vectors. So for unit vectors, we can write it as A dot A equal to B dot B equal to C dot C is nothing but 1. Now we need to find the box product of ABC. Now let's do this square. What we'll get? It becomes ABC multiplied with again ABC. Now if we write in terms of determinant, we'll get it as A dot A, A dot B, and A dot C. Now the second row becomes B dot A, B dot B, and B dot C. And the third row becomes C dot A, C dot B, and C dot C. This is the determinant. Now we know the values, all the values of here. That is A dot A is nothing but 1. This will be half. This will be half. Half, 1, half, 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 and 1. Now just find its determinant. You will get it as 1 minus 1 by 4 minus half into half minus 1 by 4 plus half 1 by 4 minus half. You will get it as 3 by 4 minus of 1 by 4 and here minus 1 by 4. That is, sorry, it becomes 1 by 8 and here also 1 by 8. We'll get it as 2 by 4, that is 1 by 2. But this is the square one, right? ABC square. But we want just the box product of A, B, C. That is nothing but plus or minus root of 1 by 2 plus or minus 1 by root 2. So this is the required answer to this question.